Welcome to the next part of the local OpenKubes demo. In the first video, we built OK Management Local and OK Infra Local as two separate K3s clusters. Now we use that foundation to deliver a real-time platform capability. Ollama runs as a CPU workload on the infra cluster, on the management cluster, an XRD, and a composition expose an Open WebUI platform API. The user does not install Helm chart directly. Instead, a make target creates an Open WebUI claim, and a cross-plane with provider Helm reconciles that request on the target cluster. We finish by checking both clusters, opening a WebUI, and sending a real prompt to QWEN 2.5.0.5b. Every command shown in this tutorial was executed successfully before delivery. We begin exactly how we left off last video. Make status shows both multipass virtual machines. Make notes all queries both Kubernetes APIs through separate tunnel kube configs. OK Management Local is the control plane for platform intent, while OK Infra Local is the workload target. We also show the pods in crossplane system, deployment runtime config default, and the installed providers. Crossplane core, provider Helm, and provider Kubernetes are prerequisites from the platform bootstrap, so this tutorial verifies them but does not reinstall them. The patch and transformation function belongs to this project and will be handled by WebUI setup. This separation right here is the central idea of the tutorial. The management cluster stores the desired state, the Open WebUI claim, its XRD, the composition, and the crossplane Helm release. The workload cluster runs the actual software, Ollama, Open WebUI, services, stateful sets, and persistent volumes. Provider Helm connects both sides through a provider config named OK Infra Local. The claim exposes only the target cluster, the Ollama endpoint, and the target namespace. Chart repository, chart version, and Kubernetes implementation details stay inside the composition. Users request our platform capability while platform engineering controls how it is delivered. This is the key difference between the platform workflow and running Helm installed directly on the infra cluster. Ollama runs as a Kubernetes workload on OK Infra Local, not as a process on the multipass host. Make install Ollama generates the namespace, service, and stateful sets manifests in the repository, applies them with the infra tunnel kube config, and waits for the rollout. The stateful set PVC keeps downloaded models across pod restarts. Make pull Ollama model downloads QWEN 2.5.0.5b into the persistent storage. The model is approximately 397 megabytes, which makes it appropriate for this CPU-based 8 GB demo. Make Ollama status shows the stateful set, pod, service, and PVC. The service is intentionally internal. Open WebUI reaches it through the full Kubernetes DNS name on port 11434. The project describes the infra connection and the XRD setup as several individual connections. The current repository intentionally bundles them in the top-level make WebUI target. It first validates the management tunnel kube config and the direct infra local kube config. The infra file must not contain localhost because provider Helm runs inside a pod on the management cluster. Localhost would point back to that pod's own network namespace. The target then creates the infra kube config secret, provider config OK infra local, the patch and transform function, the XRD, and the composition. It also creates platform/AI/OpenWebUI/crossplane automatically. During live acceptance, the secret contained the direct server address 192.168.252.168 on port 6443 and provider config, function, XRD, and composition were all created successfully. Make WebUI deploy is a separate and necessary step. It first ensures that the OpenKubes system namespace exists. Next, it generates a claim YAML file for OK Infralocal, applies the Open WebUI claim to the management cluster, and waits until the ready connection becomes true. Defaults in the makefile already provide the correct cluster, Ollama endpoint, and target namespace. Crossplane maps cluster ref to provider config OK Infralocal, and provider Helm installs Open WebUI chart 14.6.0 remotely on the infra cluster. A successful make target proves that claim reconciliation completed. It does not replace runtime verification, so we later inspect the pods, services, and PVCs on the target cluster as well. The generated claim is the visible OpenKubes platform contract. ClusterRef selects the target and the composition maps it to Helm provider config OK Infralocal. Ollama endpoint becomes a chart value and points to the ClusterRP service in the Ollama namespace. Namespace determines that Open WebUI is installed in the Open WebUI namespace. Users do not need to know the chart repository, chart version, stateful set details, or storage settings. They describe only the desired outcome. The composition translates the small API into a cross-plane Helm release. The implementation can therefore evolve without changing the user-facing contract. Acceptance is deliberately checked on both clusters. Make WebUI status queries OK management local and shows the claim, the composite resource, and the crossplane Helm release. In our verification, both claim and composite were synced and ready. The Helm release reported deployed, revision 1, and chart version 14.6.0. We then use the infra-tunnel kube config to show pods, services, and PVCs in the Ollama and Open WebUI namespaces. Ollama runs with a bound 10 GB PVC and service port 11434. Open WebUI runs with a bound 2 GB PVC. A managed cluster query returns no Open WebUI pods and no Open WebUI namespace. This proves that the application runs only on OK Infralocal while its desired state is managed from OK Management Local. Finally, start a port forward directly to the Open WebUI stateful set on the infra cluster and Open localhost on port 8080. On first startup, the pod can already be ready while Open WebUI is still downloading additional embedding data and is not yet listening on port 8080. If that happens, follow the logs briefly and retry. Without a GPU, token generation is expected to be slower. This completes the verified path from platform claim to local model response. Thank you for watching.